To start off, what is an elliptic integral? And why do we need hypergeometric functions? If you take the sum from n equals 0 to infinity of x to the n for some x, as long as x is a positive number from 0 to 1, well, actually it can't be less than or equal to 1, just less than. If this is between 0 and 1, it converges to this expression, and that's to be fairly easy to see. Actually, this works from minus 1 to 1. And it's also the origin of the belief that 1 minus 1 plus 1 minus 1, etc. is equal to 1/2. It's a misleading analytical extension. That's a geometric function. What's a hypergeometric function? Well, here, our common ratio is x. That's usually a common ratio. But for hypergeometric series, we are not afraid to make the common ratio not just a function of x, an arbitrary function of x that's rational, but a function of the index as well, which makes things even more complicated and allows a lot more things to be classified as hypergeometric. Like, for example, e to the x, well, that's x to the n over n. As you can see, this guy is just x over n plus 1. That is classifiable as hypergeometric. What about arctan x? That's also hypergeometric. Arcsine x, also hypergeometric for the same reasons. A lot of things are hypergeometric. Not all, obviously. And here's the weird part. Because the vast majority of hypergeometric functions, especially the useful ones, aren't as elementary as these guys here. E to the x, arctan x, a polynomial function. Wait, no, that's not it. This function, which is just 1 over 1 minus x. All of these are pretty simple to work with, or have pretty simple properties. But hypergeometric functions are not elementary in the regular sense. They can't be written as a composition of these guys or these guys. In fact, the only ways they can be written usually are as an integral or as an infinite series. So, where's a primary use for these guys? Well, they come up a lot in number theory and combinatorics, but you want to know the biggest case they come up in and the reason why they were invented in the first place? Well, there was this mathematician named Jacobi in the late 1820s, and he was trying to find the circumference of an ellipse.